So hello everyone. My name is Sanlu Yang, and I will give a brief introduction of the project that we are doing for the Big Data Finder project. So the project we are working on is called an enhanced route navigation system based on real-time traffic prediction. So this project actually originates from a very simple idea. So in daily life we always want to make some predictions about the traffic based on some past experiences. For example, we'll see whenever we want to drive, we also want to avoid going into some specific streets, especially during rush hours, because we know that in rush hour the traffic of the streets can become really worse. So in the first place, we're thinking about, can we, instead of using some past experience or historical data, can we make a real-time prediction? That is to say, can we gather the information of the traffic status at this specific point, and then we run a machine learning algorithm to predict the traffic levels at a specific region, instead of purely using the historical data. So the biggest problem of using the historical data is, for example, if there is a traffic accident happen at a specific street, the historical data will not tell you anything about it. However, if you're using a machine learning algorithm, then the algorithm might take a look at the traffic status within the past few minutes and might sense a huge increase of the traffic levels near the certain areas, so it might predict that there will be a huge traffic jam after a certain time period. And that is the essential reason we want to use a real-time prediction navigation system. So as you can see, we have gathered a lot of data from different databases, and we did a data cleaning to obtain 4 million training records. And we made some comparison between the logistic regression and the two-layer perceptual regression model. So we made some optimizations, and finally we achieved a nearly 95% accuracy with the logistic regression model, and that is the model we will be used for our future navigator. So let me briefly talk about the general infrastructure of the software. So essentially, the software is divided into two parts: the front end and the back end. So in the front end, essentially it gathers the user's information. So for example, the position of the user, the start point, and where he wants to go, and then it will build a graph and pass the graph to the back end. So the back end will then subtract a subgraph based on the original graph, so as to minimize the computations, and then it will divide the subgraph into different time regions, so that divided into different time regions based on the distance between this region and the start point, so that we can use different pre-trained models to make traffic level predictions for different regions. And then we assign a specific cost for different traffic levels, and we use this kind of cost to update the subgraph. And finally, we run a Dijkstra navigation algorithm onto the updated subgraph to finally obtain the route and the graph, and then pass it to the front end to display it to the user. And here is a typical graph that the front end will show to the user. So the user will find the source, that is the point that he wants to start, and the destination node, that is the place he wants to go, and insert these two numbers into the backend. So the backend will then try to subtract a subgraph based on the original graph, and basically it follows an arbitrary rule. It just allows 3 more steps relative to the shortest path, and it only considers all the nodes and edges that satisfies this rule. So after it obtains the subgraph, the backend will further divide the subgraph into different time regions. So for example, we will say that we will expect that any nodes or edges in the blue region will be reached within 20 minutes, and those in the yellow region will be reached within 40 minutes, and those in the cyan region will be reached within 60 minutes. So in that case, we will be able to make different predictions for different time periods, so that we can use different time models to predict for different time regions. And here shows what we did in the prediction part. So we used the current traffic level for the first region, and then we used two different prediction models to predict for the traffic in different regions for different time intervals. And then we assign an arbitrary cost for different traffic levels and use this kind of cost to update the traffic levels in different regions. So it shows that we update the traffic levels in the 20 minutes region, 40 minutes region, and also the 60 minutes region. So after we have already updated our subgraph, we'll then perform a navigation based on a Dijkstra navigation algorithm to predict the shortest path on this subgraph. And here's the result. So we further made a comparison of an algorithm with prediction based and an algorithm without any prediction. And as you can see from the graph, so the biggest advantage of the prediction based navigation system is that it can foresee the traffic levels in the future, so that it can predict that there will be huge traffic jams on specific streets, so that it can avoid going into that streets in the first place it tried to make the navigation. And on the other hand, if you're using a no prediction based navigation system, it will not tell you anything about the future traffic flows. So you will directly go to this very crowded regions in the future, and that will make some inconvenience for your driving. And that's all for our project. Thank you for your attention.